This is Chapter 3 of Learning Web Design, which covers some common web design trends and their motivations. As always, please read the chapter in addition to watching this video. The book contains details that are not covered here. The chapter starts out with a discussion about how web designers almost never know exactly how the pages they create will be viewed. This would be so much simpler if we just had a standard web browser that everyone used and was always kept up to date. However, with the diversity of devices, browsers, and users out there, there is no such thing as a standard web browser anymore. And there never really was. The web as we know it, more or less, was born in March 1991, the creation of Tim Berners-Lee, a computer scientist at CERN, a European physics lab. Tim was working on a new way to share and link physics papers based on the idea of hyperlinking, which was popularized in the 1980s by HyperCard software for the Macintosh. The papers were all text except for the links, which acted much like you'd expect, allowing citations to link to other papers stored on the same server. It was very much a work in progress, with Tim and others working on and improving the software as a kind of research project. From this humble start grew what we now call the web. In 1993, a supercomputer laboratory at the University of Illinois joined in on the web browser research project. The result was NCSA Mosaic, the first web browser to allow images to be shown in line with text. The software was largely created by students, with funding coming from federal grants. In 1994, the students at NCSA left to form Netscape Communications Company, which quickly released Netscape Navigator, the first commercially successful web browser. Almost immediately it became a standard of sorts, except that the software features were very unstable, with new features being added and changed on an almost daily basis. In 1995, the company's IPO ignited the late 90s .com boom. In 1995, Microsoft released Windows 95, which was a huge improvement over Windows 3.1. It had a pretty curious omission, however. It did not come with a web browser pre-installed. 6 months later, Microsoft released an update to Windows 95 that included Internet Explorer 2.0. Many new users thought that IE was the Internet, a crafty bit of marketing that proved a source of consternation for technophiles for years to come. One interesting little factoid. The original source code for the development of Internet Explorer 1.0 was licensed from the NCSA. Thus, the students who formed Netscape actually wrote the software for all popular browsers used at the time. By 1997, what started as a rivalry between Netscape Navigator and Internet Explorer became an all-out war, with each side trying to lock in users by providing non-standard features that would not work in the other browser. In 1998, it became clear that Internet Explorer had the upper hand. At the urging of IBM and others, Netscape responded by releasing the source code for Netscape Navigator under an open source license. Thus was born the Mozilla Open Source Project, which still exists as the Mozilla Foundation. The gambit didn't work, however, and Netscape Navigator started a slow exit from the field. When AOL bought the company late in the year, much of the engineering talent at Netscape left to pursue their own .com dreams. By 2001, Internet Explorer 6 had almost 90% market share, with most of the non-users being engineers, like me, who made a conscious decision not to use the product. With all competition wiped out or co-opted, Microsoft declared the browser wars over and halted further development of Internet Explorer. There was no turning back. They had dissolved the division that wrote the software and reassigned the engineers to other projects. Of course, they neglected to fix all the numerous bugs that remained in the software, leaving web developers to deal with the consequences. Back then, we actually spoke of our pages being bug compatible with Internet Explorer. The next several years were a terrible time for many web developers, some of whom used a kind of gallows humor to make light of their drudgery. One bright spot was the release of Mozilla Firefox in 2004. The new browser, which grew out of the ashes of Netscape's failed open source project, promised to comply with all web standards. Though Firefox's market share was tiny at first, web designers saw it as a hopeful sign of things to come. In the second half of the decade, competition heated up again. With Microsoft restarting the IE project, Firefox slowly gaining market share, and new browsers like Safari entering the field. Notably, the new iPhone, introduced in 2007, came with Safari, kicking off the modern age of the mobile web. In late 2008, Google joins in, releasing the Chrome web browser, which quickly becomes a major player in the field. However, the fastest gains are being made by mobile web browsers on iOS and Android. Today, the BYOD movement, which encourages people to bring their own equipment with them wherever they go, is challenging the most basic assumptions about the typical web browser. While in some ways this trend is pretty liberating, it also means that there is an even greater need for standardization today than ever before. Otherwise, how can we get all of these devices to interoperate? This leads us to the first big idea, device independence. A client device could be almost anything. A workstation, a laptop, a tablet, a smartphone, or even an embedded device without a screen or keyboard at all. With such diversity, it's perhaps not surprising that compatibilities take up so much of a web developer's time. Ideally, all devices and browsers should just stick to web standards. In fact, that seems to be the case with many of the newer versions of the popular web browsers. It's actually a good point of pride in market share to be the most compliant browser on the market. However, older browser versions are still in use, with even IE6 from 2001 being used in some corporate environments. This provides quite a challenge to the modern web designer. Do you follow the current standards and allow your users to partake in the latest technical advances? Or do you design for the old versions? Most developers try to follow a middle road, providing some limited support for obsolete browsers. To see the challenge at work, here is a snapshot of the Fairfield University website as it appeared in IE6 in mid-December 2013. It's not a pretty sight, no pun intended, but at least all of the content is still accessible. The next version of the website is likely to follow the same path as Google, which ended support for IE6, IE7, and IE8 some time ago. It was just too costly to be bug compatible with these old browsers anymore. Big idea number 2 is to stick to web standards. While I neglected to mention this in my history lesson, Tim Berners-Lee, the web's inventor, is still actively involved. As director of the World Wide Web Consortium, or W3C, he works to define and refine what constitutes the right way to do things. If you're a web developer today, best practice is to avoid non-standard methods and technologies, using them only if you're willing to be responsible for the consequences. In a sense, web designers have to own their work and no longer say that IE made them do it the wrong way. So the idea is to use vanilla web technologies that are supported by the standards, pushing for recent standards as your user base allows. You'll use HTML4 perhaps, which came out in the 90s, but it's giving way to HTML5, which provides lots of improvements for users and developers alike. Similarly, CSS2, which came out a decade ago, is being replaced with CSS3, making it much easier to develop for the mobile web. Finally, we now have commonly used and supported JavaScript libraries that fill in some of the gaps between the older browsers and the new ones. To summarize the situation with obsolete browsers, the short-term workarounds are either to stick to the old ways until forced to change by your users, or use the previously mentioned JavaScript solutions to put band-aids on the old browsers. The longer-term strategy is to trust in the following premise. If everyone designs to standards, then the burden shifts from the designers being bug compatible to the browser makers complying with those standards. In this way, we're all in it together, an attitude that would have prevented a lot of heartache over the last couple decades, I guess. Big idea number 3. Making this trade-off between the old and the new is the rationale for progressive enhancement. The general idea is to use the simplest means that actually works by designing sites to work on the lowest common denominator device used by a significant proportion of the users, and then adding optional enhancements as newer devices support them. Progressive enhancement affects all aspects of design. Authors need to produce clean and simple HTML to eliminate potential bugs. Styling needs to adapt to the capabilities of each device. And JavaScript should not be used for things like submit buttons. Instead, pages should just work, though perhaps in a more modest way, even when JavaScript is turned off. One can really see progressive enhancement at work in mobile web design, where small screens and fat fingers replace larger screens, mice, and keyboards on our desktop computers. In such an environment, content works best in one column, with long pages, simpler menus, and limited use of graphics to clutter the page. However, with HTML5 and CSS3, it's now possible to use progressive enhancement to relax these design constraints for larger devices, giving everyone the best user experience their device allows. Building on the ideas of mobile-first design and progressive enhancement is our 4th big idea, responsive design. A website is considered responsive when it modifies its appearance and behavior in response to any changes in the browser. Most specifically, page designs should change in real time with changes in the size of the display or viewport of the browser. This includes rules like minimizing the use of hierarchical menus, or links to pages or non-web documents that are not themselves responsive. We'll have a lot more to say about responsive design later on in the course, but you can see examples today just by browsing around. A neat tool for testing responsiveness is included in the Web Developer toolbar in Chrome or Firefox. Navigate to a page, click the gear icon, and select View Responsive Layouts from the Resize menu. The browser then shows how the page looks in several common viewport sizes. A responsive website should look appealing and be useful in every size. Our 5th big idea is accessibility, which goes hand in hand with the other big ideas. There are many people in this world that simply can't use a standard web browser, often due to some kind of impairment. Yes, in some industries you can be sued for not being accessible. To protect yourself, it's a good idea to follow the W3C's WAI standards that provide guidance on accessibility issues. The last big idea is designing for speed. After about 1 to 2 seconds, many users will abandon a page and go elsewhere, or worse, reload the page over and over again, assuming that the server is just not cooperating. The simplest strategy is to minimize page weight, which is how much data must be downloaded to the browser with each page load. Since browsers usually store local copies of things like pictures, JavaScript libraries, and CSS files in the browser cache, it's a good idea to reuse these copies whenever possible. When caching doesn't work, it's generally a good idea to avoid extraneous use of things like JavaScript, except for when it's being used to speed up page loads. Modern browsers now come preloaded with tools for analyzing page weight and other aspects of performance. Once again, this is yet another way that vendors are competing for the hearts and minds of web developers. That brings us to the end of the chapter, which covered quite a lot of territory in just a few pages. Thank you for following along with Chapter 3 of Learning Web Design. See you later!